Good morning, dear kids. Today we will learn about chapter 3, multiples and factors. First of all, we'll learn about multiples. What is multiple? The product of two or more numbers is the multiple of the number that are multiplied. For example, 6 into 5 is equal to 30. Then the bigger number or the product is 30. So 30 is a multiple of 6 and 5. Next example is 2 into 4 into 5 is 40. 2 4s are 8 and 8 5s are 40. So 40 is the multiple of 2, 4 and 5. Now we'll learn about the properties of multiples. Properties of multiples. Every number is a multiple of 1 and a multiple of itself. For example, 20 into 1 is 20. 13 into 1 is 13. So 20 is a multiple of 1 and the number itself. Next property is the smallest multiple of a number is the number itself. If we want to write the first 5 multiples of 4, then we'll write the table of 4 up to 5 places. 4 into 1 is 4. 4 into 2 is 8. 4 into 3 is 12. 4 into 4 is 16. So, we can see the smallest multiple is the number itself. 4 ones are 4. So, 4 is the smallest multiple of 4. Properties of multiples. Every multiple of a number is equal to or greater than the number. Here we have seen the table of 4. We can see first 5 multiples of 4 are 4, 8, 12, 16, 20. So here we can see the smallest multiple is 4. Rest all the multiples are greater than 4. Next property is the multiples of a number are endless. Thus there is no greatest multiple of a number. For example, we cannot write the last number, so we cannot write the last multiple of any number. For example, we can multiply 4 with 100, 4 with lakh, 4 with million, 4 with trillion. So multiples are endless. There is no last multiple of a number. Next is how to find multiples. To find the multiples of a number, multiply it by 1, 2, 3, 4 and so on. For example, find the first 5 multiples of 7. So, we'll write the table of 7 up to 5 places. For example, 7 into 1 is 7. 7 into 2 is 14. 7 into 3 is 21. 7 into 4 is 28. 7 into 5 is 35. So, first 5 multiples of 7 are 7, 14, 21, 28 and 35. Another example, first find the first 5 even multiples of 3. So here we don't want to write first 5 multiples of 3. Instead of it, we want to write the first 5 even multiples of 3. What does it mean? In the table of 3, we can see some multiples are odd and some multiples are even. For example, 3 into 1 is 3, which is an odd number. So we will not take odd multiples, we will take only even multiples. For example, 3 into 2 is 6, 3 into 4 is 12, 3 into 6 is 18, 3 into 8 is 24 and 3 into 10 is 30. So, first 5 even multiples of 3 are 6, 12, 18, 24 and 30. And if we want to write first 5 odd multiples of 3, then the answer will be 3, 9, 15, 21, 27 and so on. Now we'll learn about factors. If a number A can be divided by number B completely, then B is called a factor of A. For example, 6 into 5 is equal to 30. In previous slides, we have learned that 30 is a multiple of 6 and 5. Now 6 and 5 are the factors of 30. 2 into 4 into 5 is equal to 30. It means 2, 4 and 5 are the factors of 40. Now we'll learn properties of factor. 1 is the smallest factor of a number. For example, 20 into 1 is equal to 20. 1 divides every number. 1 can divide each and every number. So, 1 is the smallest factor of a number. 13 into 1 is 13. So, 1 is a factor of all numbers. For example, 20 into 1 is 20, 13 into 1 is 13. A number is a factor of itself. For example, 20 into 1 is equal to 20, 13 into 1 is 13. The factor of a number is smaller than or equal to the number. For example, factors of 14 are 1, 2, 7 and 14. So the smallest factor of 14 is 1 and the greatest factor of 14 is 14, and rest all the factors lie between 1 and 14. A number itself is the greatest factor of itself. For example, 20 into 1 is 20. It means the number itself is the greatest factor of that number and 1 is the smallest factor of the given number. Every number has at least two factors, that is 1 and itself. It means each and every number is divisible by 1 and the number itself. Next topic is how to find factors. Finding factors. Is 3 a factor of 36? We will divide 36 with 3. 3 ones are 3. Then we'll copy down 6. 3 twos are 6. And the remainder is 0. If we divide any number with any smaller number and that number divides the given number completely means the remainder is 0. Then the smaller number is a factor of bigger number. In this question, 36 is divisible by 3 completely. Completely means the remainder is 0. So 3 is a factor of 36. Next is how to find factors. Write all the factors of 24. So we'll start writing the factors from 1. 1 into 24 is 24. Next number is 2. 2 into 12 is 24. 3 into 8 is 24. 4 into 6 is 24. Next number is 5. We cannot see 24 in the table of 5. So 24 is not divisible by 5. So we'll leave 5 and then we'll move to the next number, and that is 6. 6 into 4 is 24. But here we can see repetition of number has started. So we will stop here and we'll count all the factors. So first of all, we will move down 1, 2, 3, 4. Then we'll move up 6, 8, 12, 24. So all the factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. Now we will revise divisibility rules. First rule is divisibility by 2. If the last digit is even, if the last digit of any number is even, that is 0, 2, 4, 6 or 8, then the number is divisible by 2. For example, 14, 22, 36, 50, 68. In 14, last digit is 4. So the number is divisible by 2. In 22, last digit is 2. So the number is divisible by 2. In 36, last digit is 6. In 50, last digit is 0. And in 68, last digit is 8. So all of these numbers are divisible by 2. Next is divisibility by 3. If the sum of all the digits in a number is divisible by 3, then the number is divisible by 3. For example, 48. Here we can see 2 digits. It is a 2-digit number and the digits are 4 and 8. Now we will find the sum of 4 and 8, and that is 12. 12 is divisible by 3. So the given number 48 is also divisible by 3. Next number is 63. Here 2 digits are 6 and 3. We will find the sum of both the digits, that is 6 plus 3 is equal to 9, and 9 is divisible by 3. So the given number 63 is also divisible by 3. Next is divisibility by 5. If the last digit is 0 or 5, then the given number is divisible by 5. For example, 140. The last digit of the number is 0. So there is no need to divide the given number with 5. We will apply divisibility rule and we can tell whether this number is divisible by 5 or not. Now the last digit in 140 is 0. So 140 is divisible by 5. Next number is 355. Again we will check the last digit. the last digit in this number is 5. So this number is divisible by 5. Next is divisibility by 9. If the sum of the digits is divisible by 9, then the complete number is divisible by 9. This rule is just like divisibility rule for 3. Now the first example is 108. Sum of digits 1 plus 0 plus 8 is equal to 9. So 9 is divisible by 9. So 108 is also divisible by 9. Next number is 189. The sum of its digits is 1 plus 8 plus 9 is equal to 18. 18 is divisible by 9. So the given number 189 is also divisible by 9. One more thing, these two numbers are also divisible by 3 also. Next is divisibility by 10. If the last digit is 0, then the given number is divisible by 10. For example, 240, the last digit in this number is 0. So this number is divisible by 10. The next number is 550. Again we will check the last digit. It is 0. So 550 is divisible by 10. Our next topic is prime and composite numbers. Now, what do you mean by prime numbers? Numbers with only two factors, that is 1 and the number itself, are called prime numbers. For example, 2. 2 has only two factors, 1 and the number itself, that is 2. 3. 3 has also two factors, 1 and 3. The next number we can imagine is 5. 5 has only two factors, 1 and the number itself 5. So the prime numbers less than 10 are 2, 3, 5, 7. Next is composite numbers. Numbers with 3 or more factors are called composite numbers. For example, 6 is divisible by 1, 2, 3 and 6. So the number 6 has more than two factors. 6 has exactly 4 factors. So 6 is a composite number. 12. 12 factors of 12 are 1, 2, 3, 4, 6 and 12. Again the number 12 has more than two factors. So number 12 is also a composite number. Next topic is prime factorization. Numbers expressed only as product of its prime factors is called prime factorization. For example, we can write 12 as 3 into 4. But 4 is a composite number. So further we will convert 4 into the product of prime numbers. So prime factorization of 12 is 3 into 2 into 2. Prime factorization method. First method is factor tree method. Find the prime factors of 16. 16 we can write, if we divide 16 with 2, the next factor is 8. 2 into 8 is 16. 2 is a prime number, so we will circle it with green color. 8 is a composite number, so further we will divide it with 2, and 2 into 4 is 8. 2 is a prime number, so circle it with green color. 4 is a composite number. Further, we will divide it into prime factors. 2 into 2. Finally, we have got 4 prime factors of 16. It means 16 is equal to 2 into 2 into 2 into 2. 2 is repeated, 2 is multiplied 4 times. Next is find the prime factors of 45. 45 is divisible by 3. We cannot start it with 2 because in divisibility rule we have learned the last digit of a number should be 2, 4, 6, 8 or 0. So we cannot divide this number with 2. So we will start with 3. 3 will divide 45 with 3. Another factor is 15. Now 3 is a prime number, so color it with green. 15 is a composite number, so further we will divide it into prime factors. We will divide 15 with 3 and will get 5. So finally prime factors of 45 are 3 into 3 into 5. Prime factorization method. Here we have done prime factorization of 16 and 45. Next topic is highest common factor. The HCF of 2 or more numbers is the greater factor of given numbers. Find the HCF of 12 and 18. First of all, we'll write all the factors of 12. Then we will write all the factors of 18. Factors of 12 are 1, 2, 3, 4, 6 and 12. Factors of 18 are 1, 2, 3, 6, 9 and 18. Then we will circle the common factors. 1 is common in both the factors of both the numbers. 2 is common, 3 is common and 6 is common. Common factors of 12 and 18 are 1, 2, 3 and 6. And highest common factor is 6. Highest means the factor which has greatest value. 1, 2, 3, 6. The greatest number is 6. So 6 is the highest common factor. Thank you.